So starbeam. I want to say, because before I get super into it, starbeam as a project is an extraction from Ember, and I'll get into a lot more detail about what that means in a bit. But as I'm starting, it's going to look like I'm talking about something very abstract. And I don't spend a lot of time in this particular talk talking about what the plans are for using starbeam and Ember, but part of the point of it is to take what I found good, what was useful about our reactivity model in Ember, and make it more broadly useful. And so there's this weird phenomenon where if you watch this talk, there's going to be like a lot of React stuff. And that's because I invested a lot in React, Preact, and soon Vue and Svelte. I believe that if you say that something is meant to be used by a lot of frameworks, you have to like really invest in it. Like a lot of times people will say, oh, like @Vue/reactivity or whatever could work anywhere. And I've definitely been guilty of that myself. But what ends up being the case is that if you don't invest the energy in actually making it work in the other systems, then it doesn't work in the other systems in practice. So a lot of my energy has been spent on getting starbeam to work well in React and Preact, and again, soon Vue and Svelte, when the whole point of it from a technical perspective is actually to replace the thing that is already underpinnings of Ember's reactivity system. And another weird, ironic thing is that since Ember is so stable and because it's an extraction, there's not really a huge impetus to do the replacement. It's sort of like when Java did the Java 7 stuff, right? The Java 7 invoke dynamic stuff was very useful for people who were not Java, but it took like a while for Java to start using the infrastructure because the stuff that they already had was already working. And so there's a sort of a similar thing where like really the point of this whole project is to replace the underpinnings of the reactivity model system with something that's more generally applicable. But in practice, that's not what I'm working on. So anyway, so when I say everywhere, there's an asterisk. I'll get into more about what it means, like what I mean by this sentence here. But basically, the idea behind starbeam is to sort of define what a framework is well enough so that you can build in all of your reactivity stuff in a system that's agnostic to your framework, and then just glue it in. I'll get into some of the details in a minute, but what I basically learned is that when you look at something like React or really any reactivity system, there's a lot of details that are really about whatever the framework is deciding to do this moment. But under the hood, like the reactivity system itself there's a lot in common. And so the idea is it would be great if the bulk of what you had to write in order to do reactivity you could do in something that was not particularly coupled to anything. And if you stick around, I have a demo that I think will blow your mind, unless you've already seen it somehow. But I think like stick around because I'm going to keep saying abstract things, and then eventually I'm going to make the point. But I think that's part of what's tricky about the messaging here in general is if I just say this, it sounds like kind of pointless. But if I ever be like, okay, let me show you the React part of this, it will actually look cool. But then you're like, why would I use this instead of React, right? So there's this like weird thing where what I'm trying to say is there's a universal thing, but then you have to decide you care. So right now, probably like half of the work I've done so far on Starbeam has been the Starbeam React renderer. I don't have any slides about why that is, but basically, React has a lot of opinions about the lifecycle of its components that are enforced through strict modes. I think those opinions are like largely fine. I could give talks on them, but those opinions are not exactly exposed through APIs. So it takes a lot of effort to be like, for example, I want an instance of some object that is always the same for the lifetime of a component. Actually, quite easy to do in Preact. Took me like several months to get it really working well in React, right? And that's because React kind of doesn't want you to say that, except everyone needs to do it anyway, right? So anyway, so the React renderer, I spent a lot of time on. The Preact renderer is also shipping and is ready. We did a Svelte renderer like in the beginning. It's basically bit rotted at this point, and so we're going to circle back around. And then Vue and Ember are also coming. Okay, so at this point, you're probably saying like, why does this matter? And I will try to show you. Okay, so I'm going to start by just showing you the very basic API, and then I'm going to build up from there. So the very basics of the API are you have an object called cell. Cell is just a thing that stores a variable. So in this case, it stores a number. You can make functions that work with it. So imagine you just made an object that had a current property on it. Obviously, you can make a function called increment and update it. And actually, that should say counter.current. So counter.current would be 0. You increment. You expect counter.current to be 1. This is all like pretty obvious. Like this is like what you would expect, and that's the point of it. The reason that it's worth saying is that if you, for example, try to map this onto set state or the use state, these things are not true about those systems, right? So the reason why that's the case is that basically in all reactivity systems that are not Glimmer inspired in some way, there is a batching problem where you set some variable somewhere, and then there's a process by which that variable takes in some way or another before it can be read on the other side. So I think the obvious case is in React, you say use state, you get back a count and set count. When you call set count, that doesn't obviously magically update the local variable that you have there, right? And it's not a big problem necessarily, but it just means that you can't just like go off and continue writing code like you would expect. Okay, so that's great. I just showed you that I kind of didn't show you a reactivity system at all yet. All I showed you was a very simple API that you could write in like 5 lines of code yourself. So what's the point of this? And basically the story is, and I actually want to point something out here, which is I showed you using regular functions. That's another thing that Starbeam lets you do. Like basically in all cases, if you want to update something or compute values, you can just use normal functions. There's never any point where you have to like plug into some deriving function or something like that. That never happens in Starbeam. And so in some sense, like a lot of what I have to do when I'm teaching people Starbeam is to be like, like you don't have to worry about it, and then I have to like remind them why sometimes in other systems you have to worry about it. So anyway, this is not very interesting if all you have is an object that you could put some values into and use functions. Everyone in this room already knows how to do that. So the other half of the equation is basically something called a renderer. And a renderer is just a system that keeps an external output in sync with the reactive value. So I'm going to show you code in a minute, but basically what is a renderer in principle? It subscribes to a reactive value. Like when the subscription fires, it schedules an update to the output. And importantly, if you're writing the React renderer or the Vue renderer or something, you want to coordinate all the updates for efficiency, right? So if you're writing the React renderer, which, like I said, is about half the work so far on the whole project, you want to make sure that like React already knows when it's going to render all the components. It already knows how to do it in what order. It already knows about things like use transition and use deferred value. Like all those things are already part of like the React scheduling system. So if you're writing the React renderer, you really want to you don't want to be like doing things forcibly. You really want to just be telling React, hey, there's something to do. Like that's what you want to be doing. So basically, what is a renderer? Like it takes some reactive value or reactive computation, subscribes to it, and whenever Starbeam tells you that something happened, it schedules something to happen later. If people are familiar with the Unix readiness model, like the way sockets work, that's basically a similar system where you can basically be like, hey, I have this socket. I'm ready for some data. The kernel is going to like do something, but all it's ever going to tell you is like there's something ready, like in contrast to how like Windows works, where like the kernel actually does things for you, right? So in the Unix model, basically when you have like a file to read or a socket or something, all you do is say, hey, whenever there's something to do here, let me know, and then I'll take care of doing it at an appropriate time. It's sort of a similar model, right? It's a similar model where you get notified pretty eagerly, and then it's your job to schedule things. Okay, so there is something in the code base called the debug renderer, which basically only exists for talks like this. I think, like I could imagine reasons that it could be useful in real life, but I think generally speaking, it is useful as a small encapsulation of what is a renderer. Otherwise, you'll see in a second why it's not like a good, like you're not going to want to use it, because basically the TLDR is there's a lot of systems. There's React, Vue, Ember, Svelte, Solid, whatever, and every single one of those systems does a lot of work to try to coordinate all the updates to be like top down in your component tree. They try to make sure that if a component disappears, the child components don't randomly do work for no reason, right? There's all these things that happen. Plus, there's all this extra work around like making things efficient, making sure that paints don't get blocked, et cetera, et cetera. So in real life, you would not actually want to write the code that does the DOM updates yourself, even though it's not hard. Like I think the person who works on Solid usually uses it as an example. I personally don't, I like the example, but I really think it's very misleading in terms of what a real life system is. But anyway, so we have our counter and we have our increment function. And I'm just gonna use the DOM API just to show like the very simple basics here. So we're gonna make a text node and we're gonna set it, we're gonna make its initial value, whatever the current value of the counter is. I think the DOM actually would let you just pass a number there, but probably I should have coerced it to a string or something. And then we're gonna append the text node to the body. Then we're gonna make a button. We're gonna, like it's gonna have the plus plus on it. And then whenever you click on the button, we're gonna call the increment function. Okay, so that's basically the DOM wiring up of the previous slide. Like that's the, like, how does it matter in real life, right? Like in real life, there's state, in real life, there's human beings, in real life, whatever. So this is the real life version. So the debug renderer, like I said, is really just it's just a way of demonstrating what a renderer is. The reason this works is because it's only one node, right? As soon as you have trees of nodes, it's just like now you have to do a bunch of other work. Like it's not even that hard. It just like would be a bunch of slides, and I would have to explain a lot of things that would be not very interesting, not very relevant. So basically, the debug renderer takes a reactive value. One thing that I actually don't cover at all in this talk, but is relevant, is that there is a notion of a reactive value. So the cell is a reactive value, but there's also something called a formula. I'll talk about resources later. So there's formulas, there's cached formulas, there's resources, right? So there's a bunch of things that are reactive values, and those are the things that you can give to a renderer to do something with. So in this case, you're like, please render the counter. I will talk a little bit later about like why this is not the same thing as an effect or use effect or something like that. But like that's a good question for you to keep in your head if you're wondering that. Like think about it. I'll get to it later. So basically, what does render do? So in this case, in the real implementation of a renderer, you get the callback that you get back happens synchronously, like as soon as anything happens. So really the only thing you could possibly do in that callback is schedule. The debug renderer has a little convenience for you, which basically says, like, how do you want me to schedule this? Again, not very useful because in real life, just because you schedule this one text node to update in a microtask doesn't mean that you like coordinated it correctly with the rest of your tree, right? Like really you want to have one top-down revalidation pass that sorts all the DOM nodes by document containment order and something like that, right? But in this case, we only have one node, so we're going to basically say how I want you to schedule this is queue a microtask, and that's basically just a convenience for setting a local variable that's like, did I already queue the thing? If I already queued it, don't do anything, I'm good. If I didn't already queue it, queue microtask, do the thing in the callback. Set the flag a bunch of times. Okay, so that's what a renderer is. Now I want to show you like that's, I think, like I said, that is it. Am I going backwards? Going the wrong way. I see. So this is like a renderer in the Platonic ideal. Like I think what a renderer in every system is going to be something that feels idiomatic for the system in question, right? So in React, the idiomatic way of interacting with the React renderer is a hook, right? So don't worry, I'm going to talk about why. Obviously, this is a simplified example, and I mean, it's nice. Actually, there's a lot of state libraries that basically are like, look at us, you can have module scope state. I don't personally think that's a great idea, but it does work if you want to do that. So basically, we'll take the previous slide, like we have the counter, we have increment function, and then use reactive is basically just a function that you call with a callback. The callback returns any value, and that callback is allowed to read from reactive state. And that basically what that does is it creates an ad hoc reactive value, right? So the callback is basically a reactive of some JSX element in this case, and use reactive is just basically subscribing to that ad hoc reactive value. So other than the fact that you have to wrap it and use reactive, it works just like any other React system. So like you return JSX, you say counter.current, your button works just like you would expect, etc. When I get into the demo, I'll talk a little bit about the issues with having a single instance of something, because that issue of, that could be its own talk. The issue of, I just want to have one instance for the lifetime of this React component that I would like to stick around across re-renders and like get properly cleaned up. That is not like a thing that React has in its API, right? So if you need it, which like in this case, I'm cheating by just making the counter being in scope, but if in module scope, but if I just wrote const counter equals cell 0 in the component, obviously that's going to keep regenerating. It's pointless. You can't change it and expect anything to happen, right? So there's a problem in React that is addressed with a different part of the renderer. But anyway, I think that's, by the way, the biggest mismatch between React and like basically every other reactivity system is that the need, like every reactivity system wants to have some kind of stable values that represent your reactive values, but React doesn't give you an easy way of having stable values at all. Okay, if you're thinking yes it does something use memo whatever, go read the documentation about React 18 strict mode and then like get back to me. And that's also what I thought like a year ago. It's just not true. Okay, so Preact. So Preact is interesting because Preact in principle is really just like the same thing as React. However, Preact has a bunch of different opinions. Like where React wants to leave a lot of room for them to maneuver in the future, so they don't let you assume anything, and they really use strict modes to like circumscribe. Like if you do this thing, you're like, we are telling you that that's bad, and they like run things a lot of times just to like stop you from doing anything that might allow you to notice basically where is the component instance, right? So in React classes, like the old React, you have a this, it's the component instance. In new React, like what is the component instance is like not really exposed. Whereas Preact, like, but you probably think, oh, it's like use memo or like use state or something, like use ref. Not true, but in Preact it basically is true. So basically in Preact, and additionally Preact has a plugin API that lets you like do stuff in the lifecycle of every component. So it would be great if in React I could just like wrap that use reactive around everything. That would be awesome, but I cannot do that in React. But in Preact you actually can. So in Preact you just don't need to write the use reactive thing. It basically happens automatically as a plugin to Preact that gets installed. Okay, so like I said, you're probably like, okay, that's cool. I like that you have one cell, but I want every component to have its own state, and that seems like important. So basically, there are two ways I could go from here, and I have decided to go in the universal design side. So basically, one direction I could go is I could show you how to do it in React, and then I could show you how to do it in Preact. I could show you how to do it in Vue. But what I want to do instead is show you how to write a piece of reusable reactive state that then you could use in every framework, right? So the downside of this approach is that now you're still like, I have no idea what the point of this is. But basically, a resource is just an object that lets you, you might say, oh, it looks like a class. Well, that's great, except like React doesn't make working with classes very easy. So there's just some work. If you want to really make something universal, you're not going to be able to get away with just using a class. So you could if you want, and I'm actually a big fan, and now that decorators landed, I like want to work on making that really ergonomic. But basically, at a basic level, a resource is just an object. The top level runs one time, and like however you glue it into your framework, it's going to be guaranteed to run exactly one time. That's the point of it. And then the thing that you return back is the thing that you're going to get every time. If you're working inside of a system that already has classes and has like a first, like even solid, which has like a first time and every other time, this is going to feel like, okay, I already know how to do that, right? But if like this is basically giving you a way to say, here's the constructor, and here is the instance, and now like whatever framework you're gonna like, Starbeam has figured out how to make that work. So like this is very simple. You could write a class version of this, obviously, it would be fine. So now, how does the React renderer work? Well, there's a use function. I think I need to rename this because now React has its own like use paren, so probably need to rename this to something else, maybe use resource or something. But basically, you see here that the counter that is being passed in there is just it's a reference, right? It's not like you didn't call it yet. And basically, behind the scenes, all that work that I said took me a long time to do figure out is happening to make sure that the thing that you get back from the other side is the same instance every single time. I again could, like I said, could be its own talk, but one thing that is like interesting, like I'll put a bee in your bonnet or whatever, bug in your head to look into. React 18 basically has created a new semantic, which I personally call deactivate and reactivate. You can call it remount. Unfortunately, nobody has given it a name, and that's part of the problem. But React basically is allowed as a React 18 to take a component, run all the cleanup callbacks from like use effect and use layout effect, even with like empty brackets. I apologize if people don't know React. And like I said, there's a talk about other things, but this is what it is. Anyway, React can call those cleanup functions, and then it can call the callbacks, like whatever you pass the use effect or use layout effect, React can call that again after it called your cleanup functions. So that, I think that's like logically deactivate and reactivate, in my opinion. And what Starbeam's opinion about that in the React renderer is every time your React component gets deactivated, that counts as like a full-on like cleanup. And when it gets reactivated, it counts as a full-on like fresh component instance. So you get a new instance of everything. We're kind of forced into that because React doesn't tell you like this is the last time ever. Like, so if you basically need to actually take any opportunity to clean things up, or you might fail to clean up, which means that you have to like aggressively, when React says time to clean up, you have to treat it like it's a real request to clean up. There's been like a lot of internet people who are attempting to find a workaround. My personal opinion on that is it's impossible to find a workaround because they really, really want to create this reactivation semantic, right? So basically from like, the point is that in strict mode, the const counter, if you like console log it, you'll see that you get 2 instances of it. But that won't end up mattering because every other part of the renderer is going to make sure that you don't like accidentally keep hold on it or something. Okay, so anyway, so the point is that that's how the React renderer works. So you were able to encapsulate that counter logic, and now you got an instance. The React renderer, I'm kind of just like, I guess I didn't put the little note here, but I'm kind of beating a dead horse here. Like, basically, it's the same thing, except you never need to write use reactive, right? I think it's not always true in the implementation right now, but my intent is for there to be like perfect parity between the React and Preact renderers, except that the React renderer might make you type more things. And I'll show you once I get to the demo, like one of the feedback I got early on is how to help you notice that you've made a mistake if you forget to use reactive. Okay, so far I think so far I gave you like, if you are interested in Valtio or something, or like Zushtan, one of those things, like I think this is a good entrant into that space. And I think solving the strict mode stuff is good. Like I think some people have told me like, oh, I'm using React 16. I know I need to migrate to React 18. I'm just going to like use Starbeam as a bridge because basically I know for a fact that if I migrate to Starbeam, you're going to help me make sure I don't mess up those double render stuff, right? So that's like, I think that's a good library. But there's more going on, which is cleanup. And I think, by the way, in my opinion, the reason that that hooks were so popular and why they worked is because before hooks in React, and like basically the wider ecosystem, more or less, there was not a good way of composing cleanup, right? So I think the only thing hooks really add on top of what existed before was there's a nice way of composing cleanup. You call a hook, and that hook doesn't have to be like a subclass of some component object. It's just allowed to have cleanup in it. And so you can like basically break up your logic into however many functions you want, as long as they're all hooks, and they don't have to subclass from anything specific. They don't have to know where they are, and they're allowed to add more cleanup. So I think that's good, and that's also where resources start to get interesting. So resources so far, like I showed you, it takes a callback with no parameters, but it actually does take a parameter. And so the first parameter that we're going to look at is on. And so on basically like there's more to it in the fullness of the API, but the primary reason it exists is to have on cleanup. So this is a pretty canonical thing. If you've like seen this example, this is basically like, okay, I want to have a reactive value. I want that reactive value to represent the current time, and I want that to keep changing. Unfortunately, in order to do that, I need a set interval. In order to have a set interval, I need to clean it up correctly. And so there's a pattern that you need to do that, and this is the pattern in in Starbeam. One thing I will say is there is no caveats to this pattern, right? So this pattern is the actual set of things you need to make this work. There's no like, what if I ran twice or whatever? Because like I said, if React runs you twice, no problem. We cleared the interval and we set it up again. Also, no big deal because that happened. Like the whole point of that system is that React is like running the cleanup very quickly before anything happened. And so like, is it great? No, but that's the whole point of what React is doing is to try to get you to like do what we're doing, right? So like basically, the cleanup runs, it's kind of gratuitous, doesn't happen in production, happens in development, and you would never notice. That's how it works. So basically, from your perspective, a resource is just like hooks were like this standalone piece of functionality that could have cleanup. A resource is now also allowed to have cleanup. One thing to point out about resources is that if you return a reactive value from a resource, it's kind of like a promise. The whole resource, you don't have to write that current twice, basically. The whole resource absorbs into the reactive value. Okay, so how do you use it? So you say const now equals use stopwatch, and then you say now.current, right? So basically, one thing to point out is that this is no different from any, like the fact that cleanup is involved here didn't change the data flow, right? So basically, before I had a resource that was like a value with no cleanup, and I was able to call it, and I got a value back, and I could use it. It's great. Now I have a value. It has cleanup, but it works exactly the same way. And that's also sort of like how async await improves on the previous promise story, where like previously there's like all this work to deal with the fact that there's callbacks. You have to think about the flow, like when are the callbacks happening, blah, blah, blah. And then await basically gives you this nice benefit of being able to think of the whole promise as a value. Like you never have to think, like when I teach promises now to new programmers, I always just say like, promise is just like, until you're a more advanced person, a promise is just a special kind of value. If you don't write await, it doesn't work, right? You need to write await. But actually the way the internal spec machinery works says that like when you say await, it converts the promise internals into either a throw or whatever, right? So basically an async function behaves as if you turned all that complicated machinery into just a value. And basically, like, I don't know, I don't personally like Haskell analogies, but like there's a monad there somewhere. And similarly here, like the use thing is kind of like await in that it takes something that has all this machinery around cleanup and it gives you a value back, and the value works like any other reactive value. So like earlier on, I was like, here we have a cell, and like it's not very interesting, and that's the point, right? But now that's also true about these more complicated things. They're also not very interesting, and that's also the point. Okay, like I said before, in React you have to say use reactive. In React you don't need to say it. By the way, like I'm not saying this to troll React. React just does not want to let you abstract that because they think it's better for you to type it. Totally valid design decision. I think it's just good for people to know that the consequences of that are you can't do this kind of stuff. Like, okay, so it's great that we have the ability to create a resource, and so, like it seemed like it would be pretty easy for you to figure out inside the React renderer how to like use a resource with another resource. It wouldn't be hard, but the whole point of Starbeam is to let you write larger reactive systems without ever thinking about React, and then plug it into React at the end. So we want to compose resources, and we want to do that in a way that's universal. So let's start with the stopwatch that we have already. And what we want to do is we want to make a resource that is that resource is a formatted version of that, right? So if you just had a JavaScript value, like then you would take that value. You would probably, I hope you would use intel.datetime format because that's the right thing to do. And then you would call it with your value, right? That's what you do. And in universal Starbeam, like the way that you compose resources is basically the same thing. Just like basically you get that same use function that you had in the React side, but now it's passed in as a parameter to resource, and you can use it to instantiate other resources. And behind the scenes, the primary thing that's doing for you is gluing together all these resources into the same lifetime, so that when the component that ultimately, like you're going to eventually put that resources into some component. When that component gets cleaned up, it's going to clean up the formatted now, and that better clean up the interval. Right? But you don't have to know about the interval. And in fact, the person who writes formatted now doesn't have to think about it at all. And if you're thinking this looks a lot like hooks, that's actually true. It's just that this is a universal version of that. Like at some point earlier on, we called starbeam like universal hooks, and then we realized like not everyone knows what that means or like what a hook is. But I think that's a good way to think about it. So then how do you use it? Like basically no difference. Like you say use, you get back a value, you say not current. As usual, you don't need to use it. Say use reactive and preact, but otherwise it's the same story. Okay. So I also think that at this point, like this is basically where we were at 6 months ago or something like that. The primary reason that we continued working, and towards the end of my talk, I have like a slide where I just want to talk about like what I think is a framework, like from the perspective of Starbeam. But basically, Ember has a bunch of additional features that I think are very universal concepts, but they require that the renderer for each framework has to do some more work. Okay, so services are basically just resources, but it's a resource that lives as long as the app. And perhaps you're thinking, oh, that's like, why don't I use module state? Well, you actually do not want to use module state, because if you use module state, then you have to like mock your modules. Basically, I don't know if people who've been through it, but basically putting actual app state inside of your modules means that if you want a new copy of the app for integration tests, for SSR, anything like that, you basically have to either like mock the module system, which I really do not recommend, or like you're just gonna have to like you have to rerun all the code, you have to reevaluate all your code just to actually get those little tiny bits of state, right? So I don't think that's a good idea. And the reason that it seems like it might be a good idea is because it's just like it is not always reliable to get what is the current instance, it is also not very reliable to get what is the current app. And so if you had what is the current app, it's not very hard to implement. And so that's another thing that the Starbeam rendering system wants you to do, is when you make a renderer for a framework, help Starbeam understand what is the current instance of the app. So the bottom line of this is you can turn any resource into a service. So like there is nothing special about a service. A service is just a resource that gets instantiated the first time somebody wants it, and then not again until the app, for the duration of the lifetime of that app. And then it gets cleaned up when the app is cleaned up. If you're thinking like that's not really a thing, like my app is like the same as the process, it actually is possible to unmount the component that is the root of a React app. It is also possible to have like multiple React apps in the same process. It's just not actually true that your app is one-to-one with the modules that are part of it. And in fact, like it's like a vagary of JavaScript that you could even pretend. Like I think it's not, like I personally think it's nice to just treat your modules as code and like have instances of things be instances of things as a separate matter. Okay, so basically what it means in React in particular. In Preact, you don't have to do this for the same reason. Basically, Preact lets you notice that lets you say globally, like, tell me when you're about to render a component, tell me when you're done rendering a component, tell me when you're rendering a root, whatever. But in React, you can't, like, that's not a thing. So there's a component you wrap around your whole app. You don't actually need to do this if you don't want services. Like, if you don't care about instantiating resources only for the duration of an app, then you don't need to do this, and nothing requires you to do it. But if you actually want that feature, which I like and it's good, then you need to wrap it's basically a context provider with some extra features. Okay, so that's what you do. And then basically inside of any component anywhere, you just say use service, you pass a resource, and then basically TLDR, if for the current, like I think a way to think about the app in React is it's like the current root. Like there's some instance of some root. In reality, it's like an instance of some internal React thing, but like logically there's the app. You said like render, you made a root, whatever. And if you already did it once in the duration of that same root, then you're gonna just get back a new copy of formatted now. If you didn't already do it, then you're gonna instantiate it. But importantly, one of the things that I think I've worked hard on and I think is important is you don't have a lot of nulls here, right? Like basically, by figuring out what is an app, how do we say that, we don't have to like propagate the null checking throughout your entire app, right? We're like, oh, I'll check it everywhere, right? I think basically, use service is always guaranteed to give you back an actual reactive value that is the current time, like no matter what. So I don't know. I ended up not using a ton of TypeScript in this talk, but if you use TypeScript, it becomes very apparent. Like basically the types are all T's instead of T or nulls everywhere. Okay. So basically the formatted now resource is going to be created the first time a component uses it, and it's cleaned up when the app is unmounted. Since it uses the stopwatch resource, the stopwatch will also be cleaned up when the app is unmounted. If you're thinking like it seems like you shouldn't have many set intervals, that's also true. Then you would use the service version. You would also use a service inside of the universal code, like where you use you would say service if you want to do that. But also if you didn't, like if somebody didn't already do that, it's fine. Like it basically you can always do things in app code if the universal code didn't do the right thing. Maybe this is not very important. So what we mean by universal reactivity is that like as I've been continuing through this talk, there's like more and more features being added, but in all cases they're being added to the side of the code that doesn't know anything about React, right? So React is doing like more or less the same thing every time, and you're able to express all the concepts that you need to express on the universal side. Right now, like I said, we basically only have the React and Preact renderers, but the point of the whole project is like when we add a view renderer, there's nothing else to do other than have a view renderer and everything works. Okay. I'm going to show a demo in a minute, and there is a thing like basically having good errors and debugging infrastructure is a thing that we spent a lot of time on. Right now, there are no dev tools. Like that's something that is kind of behind some cleanups, but making sure that like the internals all propagate information that is useful for debugging is already a thing, and I'll show you an example of that. Yeah. Now, before I show you the example, which is I'm about to do, I just want to show you the code that I'm going to use and like talk through it for a minute. So far I like showed you that there's a thing called the cell, and that's like very nice, but like kind of boring. There is also a thing called Starbeam collections. Like the current release version calls it starbeam.js. It's getting renamed to collections, and basically it gives you a reactive version of all of the JavaScript built-in collections. So you can have a reactive map, a reactive object, reactive weak map, weak set, set, whatever, array, object. And what I mean when I say it's reactive is that if you'll see in a second, I'll talk about it in a second, but if you interact with that object in the normal flow of your app, well, I mean, if you interact with the object inside of a reactive computation, like both the reactive computation knows to invalidate whenever the reactive object invalidates, but more importantly than that, and there's a lot of tests around this, it's a fairly granular update. So if you read a particular value from the map, updating another value in the map doesn't cause everybody who ever read from the map to invalidate. And that's actually a philosophical disagreement, more or less, with the React philosophy, which basically says like because of functional programming, and I'll get to more details soon, like I'll get to the philosophy in a few minutes, but because of the desire to use referential equality and functional programming, they basically say like, how do you update an array? You like learn how to write filter and map and flat map or whatever. And I'm not here to troll that particular point, but it does mean that there's no way to know which thing updated, right? Like basically, if you replace a map with a whole other map, like forgetting whether it's efficient or not, like there's no way to know which thing updated. And Starbeam takes the opposite perspective, which is not only do we know like you got this particular key, we also go as far as to say like if you checked for is this thing in the map, and then you didn't actually get the value, and then all you did is update that key, right? So like you updated a key, and the only thing the computation did is check if the value is in the map, then that check didn't invalidate, right? Like if you say, hey, is there like a property name in this map? And then it was, and then you just updated it to a different value, that computation doesn't need to invalidate because you just checked if the value was there in the first place. And so like there's a lot of tests for this, but in general, we try to both have a efficient implementation strategy. Like behind the scenes, we don't do a lot, and I'll talk about it soon. But we try to be as granular as possible with like what invalidation means, so that you can like really use these data structures and it works. Okay, so this is an example. I've like used it a lot in demos. This is even streamlined version of it. But basically, it's like you implement it. It's a thing called a database. I usually go down the path of making it work in TypeScript, and then I realize I wrote 10 pages of code to make it work in TypeScript, which is nice. It's nice it works, but then it's doesn't fit on a slide. So basically, what is a database? It's just like an object that contains a bunch of tables in it. When you define a table, you're just gonna make a new table instance. When you get it, you're gonna get the thing back. And then what is a table? It's a map from ID to some anything. And then here, the important thing is the rows function over there literally is just it's spreading this.rows.values. The rows itself is in a private field somewhere. So there's no good way to propagate it in a system where you have to write derived parentheses or something like that. There's not a good way to do that, right? That's what this is trying to demonstrate. Is you can put a reactive map inside of some abstraction somewhere, and nobody needs to know that along the way, right? So basically what rows is just a list. Get me all the values, get me all the keys, and then I did the CRUD operations. The thing I really want you to take away here is if you were writing the Node backend version of this, it would probably look like that, right? You wouldn't write reactive.map parentheses, but otherwise it would look something like that. Okay, so now let me show you a demo.
So as we just saw, the database is a very simple JavaScript object. And here's the same database in the real code. This is a StackBlitz. And just to quickly reiterate it, so we're using a reactive object for the tables. We're storing stuff that we define inside of there, and then we get the table this way. You'll see it used in a second. Then an actual table itself is also just a very simple wrapper around a reactive map. And again, just to reiterate, what's interesting here is that the rows is just calling rows.values, which is the JavaScript built-in values method, and spreading it. And we'll see in a minute why this is valuable, why this very normal way of writing JavaScript, basically the same way you'd write a node version of this code, will also become reactive automatically, right? So create, you see we have the CRUD operations here, create, set something in a map, read, get something from a map, update, set something from a map with a callback, and deletes an item from the map, right? So that's just a very simple wrapper around the map and some iteration. So if we go back here, the first thing we do is we use this use setup hook, and in React, that just makes sure that this code only runs one time, the first time the component is created, because we obviously don't want to be creating the database on every render. So we make the database, we define two tables, and then we create two people, Alice and Bob, and you'll see in a second, but those are these people. And then what we're going to return from here is the database itself, and then add, delete, and an all method. And the add method calls create, and it's like creating a new ID behind the scenes. Like in real life, you'd probably have an ID from a database or a UUID or something like that. And then again, the point of this here is it's just another abstraction, and Starbeam doesn't stop you from writing abstractions. You can just keep writing things in a natural way, the way you would expect to write it if you were writing the one-time version, and it will work. So use setup is just a React thing that only runs one time because React needs you to do that. In something like Solid or in Vue, you wouldn't need it because you would just put the code in the setup section, right? But here we do. So basically that DB that you get back is this object. Okay. So then the next thing that happens is we wrap everything in use reactive, and that just means everything inside of here is allowed to access reactive state from Starbeam, and it will get re-rendered if that changes. So let's quickly just go through the whole example. First of all, we make a form, so that's this thing over here. On submit of the form, we obviously stop it from reloading the page, and then we call people.add, and we get the name. So this is just a browser API that lets you take the form, turn it into an object, and then we get the name out of it. So the name is over here, right? So this is pretty boring. The only interesting thing here is that we're saying people.add and we're getting the name, and add here, right, gets the people table, creates it with an ID, the next ID, and the name that we passed it. Okay, so that's that. The next thing is we loop over the current list of people. So what's people is people.all. We're using the people.all in the use reactive block, so that means that it will automatically update whenever the all changes. And just as a reminder, what all did is it called rows, and rows is just a spread of the rows.values. So what that's a natural thing that we're trying to do here is we're just getting the values, and that will automatically invalidate whenever the list of rows is added or removed from. One thing I just want to reiterate from before is that if you only look at the IDs, which we don't happen to do here, that will only invalidate if you create a new entry or remove an entry, because otherwise if you update the value for a given ID here, that doesn't change the list of keys. So this cell, which represents the iteration of the keys, won't invalidate in that situation. Okay, so we loop over the people, and then we use a key here. So we have an ID, that's just the React requirement. And then we have an LI. The LI is going to have a title, so that just if you hover over it, you can see the ID and the name. And then whenever we click on this button, this trash button, we delete. So people.delete, just as a reminder, calls gets the database and deletes. And delete, as a reminder, just does this. And I just want to keep reiterating, you've seen all the code here. Like, there's nothing up my sleeve here. This is basically just it brings into reality the way that React kind of wants you to think about it, which is you just write the one-shot thing and it works. It's just that now you can use mutation on your root state. You still have to use regular functions to get information out, but at the root level, you can use mutation instead of having to propagate things like use state all the way through. And that just makes these kind of abstractions where you're just like putting something in a private field and stuff like that work. Okay, so that just deletes the thing. And then here's the last point is, so we're saying if people.length is 0, then say no people yet, otherwise don't say anything. And the length property invalidates whenever the, so length is, sorry, if we go back here, right. So people is all the people, right? And remember, that's just an array. I don't know why the types aren't working here. It's weird. Remember that it's just an array. And so people.length should invalidate whenever you add or remove anything from the people. And so what that means is that if I delete items and I get down to 0, it says no people yet. If I add a person here, right, then it updates. And there are blank people also updates, right? So basically the point is that the entire JavaScript API of map works. And because of the fact that one of the things in the JavaScript API of map is that you could iterate over the values, that means that iterating over the values is reactive. And that means that spreading into an array gives you back an array, a reactive array, basically. Like calling rows is a reactive operation. So whenever the rows values change, the array will be invalidated, and that will tell React to re-render, and that will result in length being the right thing. So that's basically how it works. I want to reiterate one point from earlier, which is that when you mutate something here, like using this people.delete or by using people.add, the next time you read from that object, it is guaranteed to have the update. That doesn't mean it renders right away. Of course, it would not be correct to render immediately. It's important to let React render when it's supposed to. But whenever you get around to reading from the value, which in this case will happen the next time React renders, it's guaranteed to see the update. There's no point in time where you issued the update, but it didn't happen yet. And that's a fundamental thing about Starbeam that's really nice and makes all this stuff work very intuitively.
So I want to talk like, why is it fast in the first place? Basically, it uses a system called demand-based revalidation. And so what is demand-based revalidation not? It is not push-based. If someone is trying to pitch you on push-based, which is like the solid guy, RxJS, the benefit that you get is granular updates. One of the downsides among several is that you can't just use normal programming patterns to combine your data. I think like the signal story is much better than the Rx story, but at the end of the day, like in order to create a computation based on a reactive value, you have to use a combinator, which is kind of like the .then story, right? You basically have to propagate, you have to use some kind of API to propagate it through, and like the more ambitious frameworks do a lot to try to make it happen less frequently, but at the end of the day, that like you can't actually hide the reactive value inside of private field somewhere because there's not going to be any way to propagate it correctly, and if you're not already inside of a frame or whatever. So basically, RxJS and signals are a good example of push-based reactivity. With demand-based validation, there's no hard references from cells to formulas. There's no need to communicate changes. It is also not recomputation-based. recomputation based is basically what React does. The benefit of that is that it feels like normal programming. Basically, a React function looks like you're calling a React function. If you want to compute a value based on some values, you write a function, right? The downside is that, and this is like a fundamental downside, is that you have to run the user code again to determine whether there are any updates that are needed. There's no way of avoiding that because the model of determining whether there's an update needed in the DOM is based on recomputing the data and then triple equals checking or object that was something checking them, right? So fundamentally, revalidation in a recomputation-based model requires that you recompute the value, which can be arbitrarily expensive, right? Demand-based revalidation is, I originally developed it for Glimmer for the Glimmer rendering engine. It was inspired by HTTP caching, which is like, if you think about it, you'll see it's kind of the same thing. And basically, the reason we needed demand-based revalidation, which I'll explain in a second, is if you looked at React's original talks where they like tell you it doesn't actually matter, in fact, which I think is now thoroughly debunked, but whatever. They actually like used Ember benchmarks and were like, as you can see, updating is very fast. Unfortunately, like initial render is very slow, so like it's not worth the trade-off. And so we were like, oh shit, not sure if I'm allowed to say that here. We were like, oh, we really need to make initial rendering faster, but we can't afford to actually, like, we can't do the React story because we can't afford, like, people have like chat apps or whatever. Like, we can't afford to make to make revalidation require re-executing or like arbitrarily large diffing of arrays or whatever, right? So we basically needed a solution, and so we needed a best of both worlds approach. By the way, like that same design ended up inspiring Salsa, which like if you look closely there, you'll see that like the Glimmer system is explicitly cited. More or less, the story of Salsa is that I was like, Nico, I have a better thing for reactivity. You should do it, and he was like, awesome. And then he's much smarter than me, so Salsa is much better than what I could do, but it's the same model basically. So what is the model? The model is like, first of all, you store all of your reactive state in cells. And so like fundamentally everything is quote unquote a cell. We have like some fancy, like I think the way to think about reactive object, reactive map is it's like a fancy cell. Because like when you say .has on a map, really in practice there's a cell that represents the thing. If you like do the computer science, you'll find it somewhere, right? It would not be efficient to do it that way because we really want to use, like at the end of the day, we want the gets and sets to go through like a regular map, right? So anyway, the point is that that's in some sense a fancy collection of internal cells, but actual state that could be mutated is stored in cells, and every piece of state that's stored in a cell has a revision number. Very easy to update a revision number. If you update a cell, you just like increment a number, and then you store that number alongside the value that you stored. So that is the entire cost in production of updating a cell. Now, any computation ultimately, transitively, just reads from a bunch of cells, right? So what is the revision number of a computation? It's just a maximum revision number of all the cells that were used the last time you computed it, right? So then if you want to know whether a computation is out of date, you just iterate through the whole collection of cells that were used last time, get the new maximum, check to see if that maximum is higher than the last time you checked, and that's how you know. And that process of iterating through a list and checking whether a number is bigger is something computers are extremely good at. So even if it sounds like, oh, those seem like pretty similar things, no. Like this is math.max, big list of numbers. I mean, it's not quite as, we like possibly could be as good as that, but not quite, but like more or less. At the end of the day, the only computation is comparing numbers and like some intermediate data structures. And that is always sufficient in all cases to know whether a computation that is being passed to a renderer is valid or not. The connection to HTTP caching is like, HTTP has a much more thorny version of the problem. Like you have to literally like make a network request. So they have basically a similar thing. Last modified is literally a revision counter. There's also digests. We basically don't end up Salsa uses digests. We don't because everything's always in process in front end. But like in principle, there's nothing wrong with digest. It's fine. The only rule has to be like you have to have a way of knowing whether the underlying storage changed without recomputing it, right? So basically, if you were using digest, like every cell would have a digest, and then the computations digest is the digest of all the digests you used last time, and then you loop through all of them, you get the new digest, you compare, right? But basically, in all cases, it's just the point is that you have a way of checking validation without computing, and that is always fine. That basically means that you can write code. Like you have to write .current a few times. If you use more of the reactive collections, it looks a lot more like normal JavaScript. But at the end of the day, that .current is like a pull. It's like a thing where you're getting a value and you're calling other functions, right? And no matter how complicated, the reason it's okay to put stuff in a private field is because at the end of the day, it doesn't really matter how you ended up reading those cells, as long as inside of it's called tracking frame. Inside a tracking frame, I read from a cell. That's the other piece of bookkeeping, right? Every time you read from a cell, it adds the tag associated with that cell to a tracking frame. So that's the entire bookkeeping overhead. When you update something, it bumps a number somewhere. When you read from a cell, it adds the tag associated with that cell to a tracking frame. Those are like pretty small deltas on top of like the underlying operation, right? And I think you can, in your head, you can figure out that the delta in total is like pretty workable, and that's why we're able to get the best of both worlds in Glimmer. Okay, so out of time, but element modifiers is basically like the same. Element modifier is basically, a lot of frameworks have directives. React has the ref thing. Like, wouldn't it be great if you have a resource, but it's instantiated with the element, but like not element or null. It's like instantiated with the element. When it happens, it has the right lifecycle. Wouldn't it be great if that was universal? Bottom line, like that implementation already exists. There's a package called starbeam modifiers, but like none of the renderers implement it yet, right? But I think like the point is, it's basically like the thing that you render needs to do is plug into however, like the directive system or whatever, to know for a fact when you get the actual element, and then only actually invoke the callback, like when only call the user's modifier when you have an element. That way the user doesn't have to worry about the null problem, and then also deal with, like, it's effectively a resource at that point, right? It's effectively a thing that has a lifetime that's associated with the component that gave you the element. Production mode. I've been saying this for like 6 months. Gotta really focus on it. Basically, the bottom line is, because of the really, updating a cell is incrementing a counter. In reality, it's like also like getting the call stack and whatever, and that's not fast, right? However, all those things go through like a few functions. We just need to write the code to strip it, and we just keep not doing it. But I think I think the urgency has bubbled up to the point where I will predict it in the next few months. It will definitely happen. I have also recently done a pretty big internal refresh, basically there's just a lot, like this whole project started out like a year and a half ago or something. Originally, it was going to be a new framework. That's definitely not what happened. So there's just some cruft left around. I just recently, like, I have a PR that has like really it removes all the cruft from all the concepts, like consolidates everything. It's going to land in the next probably few days, and that is happening. View render is what I was working on before I did that internal refresh. I was just like, I have to think about so many things that don't matter in order to write the view render. That's bad. So let me just like make it simpler. Then when I do the view render, it'll be easier. And then on the horizon, like the internals have all the debugging information. Like you saw, like that error message is like an ad hoc version of a good debugging tool. All the information is there. Writing an actual like UI is like, my feeling is once the internals thing lands and everything, like the kind of person who's going to be good at that is not even me necessarily, right? Like once the library is there and it's like here, it's like the person who works on Firefox DevTools has a library that gives you some information. You like make a UI. I've done a few prototypes of it, but I think I'm not a blocker basically, and I think I need to make it like really true that I'm not a blocker, and then it will happen. And then the Svelte render is actually the first render we ever built, and then like SvelteKit happened, and like we were like, do we need a compiler plugin, whatever? I think we need to circle back around to that. I think like it's kind of caught in the thorns of the SvelteKit change, but it's like very easy to understand. I think weirdly, like Svelte rivals React in terms of like getting the right hooks. Like Preact is the best framework I've seen in terms of knowing what's going on. React and Svelte both have pretty significant complexity with like just getting the lifecycle to happen at the right time, wrapping all the consumptions in something that's useful, etc. I'm not saying it's not a knock on Svelte, just like it's a complication. Okay, I don't have time for these things, but I'll just say them. Like basically one thing is like, what is a framework? So like that's like a good blog post at some point, but it's stuff like you know what your app is, you know what your component instance is, you have a notion of cleanup that could be associated with components. Like those are the things, and that is basically what ultimately like universal reactivity means, is like saying what those things are in a way that is universal enough to like express what you need to express, and then when you plug it into the framework, it like gets the high fidelity version of the framework features. Like if you couldn't use transition or use deferred value or something in React, like something is not right, right? So that's like, for example, like there's like a thing called a DOM resource, and that has like idle timing and layout timing. Like basically those are the kind of things where you basically have, it's not a lowest, it's like the opposite of a lowest common denominator, right? It's like, what are all the features that all the frameworks have will like make our system support all of them, and then like your framework may or may not be able to do a great job with the information, but if your framework is able to do a great job with the information, then it will do something useful. Render not an effect. Basically, the very quick answer here is a render is only an out, right? You have a reactive value. The only thing it's allowed to do is go out. The way use effect is used in practice is to take state from inside and send it to inside, right? That's basically not what a renderer does at all, and it is the reason I decided to, like, people keep wanting to call it effect for like ecosystem compatibility. The reason I keep pushing on renderer is because I want it to be clear that it's only about synchronizing outputs and it doesn't do anything else. Any other case where you think you need an effect, there's like another way to do it, and it's not even that hard to figure out. It's just that if you start going down the use effect path, you will not realize it. And then I'm not going to go in, like, basically demand-based revalidation and signals. I think signals as currently in the ecosystem is like the ideal push-based reactivity that we've seen so far, but it still ultimately is like, there's a hard reference from the signal to everybody who uses it and everybody in between, which means that things like just I want to put that in a React, you can't implement reactive map, right? It's impossible, because in order to consume something from the signal, you have to like use the signal API. It's like just like you can't implement React like promise map, right? You can only implement promise map if you're like everybody along the way knows that it's a promise map, right? And it's a similar thing. And the point of Starbeam is to say like we push all the bookkeeping into the cell side and the render side, and everything in between is nothing. Everything in between is normal JavaScript. Thank you.